Hello students, I hope you will be fine. Today we are bringing the second part of the video from the topic physical quantities and measurement techniques. In the first part of the video, we have discussed the physical quantities, that what are the physical quantities and what are the examples of the physical quantities. Then we have also discussed about the physical quantities such as length, volume, and today in this video we are going to discuss about the third physical quantities that is included in our IGCSE syllabus, that is the time. So starting with our video, the topic which we are going to discuss today is time. So what is time? Time is one of the physical quantity that can be measured, and the SI unit for the time is seconds. Although we know that the time can be measured in number of units, for example, the time could be measured in minutes, hours, days, months, or years. But the standard international unit which we use for the calculations for time is seconds. Now, if we talk about the measuring instruments for the time, there could be many number of measuring instruments that could be used for measuring time. For example, a clock, a stopwatch, and when we talk about the stopwatch, we have two different type of stopwatch. One is the analog stopwatch, and other one is the digital stopwatch. Now, what is the difference? The clock is a device that we all have in our home, in our school, that is used to know the current time, whereas the stopwatch is a device that is used to measure the time interval. Okay, time interval means that let's suppose there's a person who is running, and we want to know the time interval in which he completes his race. So we start our stopwatch once he start running, and then again we press the button when he ends or when he reaches the finish line. So the time interval is measured by using a stopwatch. Now for the clock, we know that the clock has the least count of 1 second, which means that the smallest time which the clock can measure is a second. And similarly, if we are using a stopwatch to measure the time interval, the stopwatch also has a least count of 1 second, which means that the stopwatch also, the analog stopwatch can also not measure the time less than 1 second. But talking about a digital stopwatch, the digital stopwatch has much more accuracy and precision compared to the analog stopwatch, and it can measure the time accurately to 0.01 second, which makes the digital stopwatch much more accurate than analog stopwatch or a clock. So that's why you see that whenever there is some competition going on, like a swimming competition or a race competition, we always use a digital stopwatch. Now let's suppose if there are two runners running in a race, runner 1 and runner 2, and both of them complete the race in 10 seconds. So we can't decide that who is the winner and who is the loser until we know that how much milliseconds they have taken to complete the race. So let's suppose the first one is taking 10.27 seconds and the other one is taking 10.25 seconds. So if we are using the digital stopwatch, then and only we can use or then and only we can know that who is the real winner. So here, because the runner 2 is taking less time and the digital stopwatch is giving us the reading with much more accuracy and precision, so we can decide that the winner is the runner number 2. Now coming to the second topic or the subtopic, that is determining the average value for length and time period. So let us suppose if we are measuring the time interval by using a simple pendulum. So we know what is a simple pendulum. The simple pendulum looks like this, that there's a string and there is some mass or a weight which is known as a bob attached to a string. So if we want to measure the time period of a simple pendulum, so the time period is the time taken to complete one complete oscillation or one complete cycle. So we take our mass or the bob to one of the extreme end like this, and we leave it from this end. So what happens is that it goes to the other end like this, and then return back to its original position. When it do like this, it completes one complete rotation or one complete vibration or one complete oscillation. So the time taken for one complete oscillation is known as a time period of a simple pendulum. Now let us suppose if we are asked to find the time period of a simple pendulum and we are doing this experiment, so of course measuring the time period of one complete oscillation is not going to give us a very accurate value, because we know that whenever we are measuring a time by using a stopwatch, there are the chances of error. For example, there could be a systematic error, or there could be a random error, or there could be a error due to the reaction time of the human being. So what we do, we use the method of taking average value. Now what is this method? Instead of taking the time for one oscillation, we are going to measure the time for 10 oscillations, and then we are going to divide the total time taken by 10. Okay, so in this way we are taking the average reading for a single oscillation, and by taking the average reading we are reducing the amount of the error, or we are making our answer more precise, and there will be more precision. Why? Because let's suppose if the reaction time is 0.67 seconds, then that reaction time is divided over 10 oscillations instead of one oscillation. So our answer will be more accurate in this way. So let's suppose we are going to take the time for 10 oscillations, time for 10 oscillations, and the time which we have measured for 10 oscillations is, let's suppose, 20 seconds. So what we are going to do is that we are going to simply divide 20 by 10 to get the time for one oscillation. So we'll get the answer 2 seconds. Now this 2 second is the time period of a simple pendulum, and it's the average time period of a simple pendulum, because we have taken an average value which is going to reduce the errors in our answer. Similarly, we can repeat this type of average for the length. For example, let us suppose if we are asked to measure the diameter of this ball. So how we can measure the diameter of this ball? We know that the diameter is the distance from one end to the other end. So instead of taking the diameter of a one ball, we are going to take the diameter of the five balls. So how we are going to do that? We are going to take the five similar type of balls. We are going to place them in a line like this. And then we are going to place two wooden blocks on each of the end. By taking two wooden blocks on each of the end, we are basically knowing, or we are able to understand and mark the initial and the final position between these blocks. So we can put the meter ruler with a zero mark starting from here, and we can measure the diameter of these five balls. So maybe 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's suppose the five balls have a diameter equivalent to 9 centimeter. So to know the diameter of one ball, so one ball has a diameter equivalent to 9 centimeter divided by 5. That will be equal to, you can do the calculation with a calculator, 9 divided by 5, which will give us 1.8 centimeter. So this is the average value of the diameter. So why we are taking this average value? Just to make our answer more accurate and to reduce any type of error which is existing in our calculations. Okay, thank you so much for today. That's all.